Welcome back to Talk Tensors. You know, we all use them every day.
LLMs.
Exactly. Large language models.
Yeah.
And they're getting better. But sometimes, like when I'm typing in a search or asking my digital assistant something, and I make like a little typo, it just totally goes off the rails.
It can be pretty frustrating.
Yeah, totally. And it got us thinking, like how big of a problem is this really for like the future of AI?
Yeah, it's a great question.
So we found this really interesting paper we wanted to take a deep dive into today called Exploring Robustness of Multilingual LLMs on Real-World Noisy Data.
Catchy title.
I know, right? So researchers over at the University of Bonn, they wanted to figure out how well all these different large language models handle those little typos that we all make, and not just in English, across different languages.
Yeah, and I thought it was really cool how they went about this whole thing, too. Instead of like just, coming up with a random list of typos, they actually built like this.
Like a dictionary?
Yeah, basically. They call it WikiTypo, and they created it by analyzing like all these edits that people made on Wikipedia.
So it's like all the real world typos.
Exactly.
That's awesome. So what did they find?
Well, one of the big takeaways is that bigger isn't always better.
Ah, interesting.
Yeah, so like you'd think that these massive models like, MT513B with all those billions of parameters would just like breeze through typos.
Right.
But turns out even they can get tripped up sometimes.
Huh. So it's not just about like throwing more data or computing power at the problem.
Right. It seems like there's something else going on here, something more fundamental about like how these LLMs actually learn and process language.
Okay, so then to really get this, we need to take a step back and look at like the history of these things, right?
Yeah, I think that'll help put things in context.
So like how did we get to these huge language models that can write, poems and code, but still can't handle a simple typo?
Well, the field of natural language processing has come a long way, and it's been really driven by this like explosion of deep learning techniques.
Yeah.
So like the early NLP models, they relied on all these like handcrafted rules and statistical methods, which, they worked okay, but they were really limited.
Like trying to explain a joke by breaking down the grammar.
Yeah, exactly. They just couldn't capture the nuances of language.
Right.
But then deep learning came along and things started to change. These new models like recurrent neural networks and transformers, they're able to learn patterns in language data on their own, like without us having to explicitly program them.
So it's like instead of telling the computer how language works, we're just letting it figure it out by itself.
Right, exactly. And that's led to some really incredible breakthroughs like machine translation, text summarization, even, creative writing.
Yeah, it's pretty amazing what they can do.
But there's a trade-off. This reliance on statistical patterns also makes these models really sensitive to like noise in the data.
So even though they're learning from tons of real-world text, they still get thrown off by anything that deviates from what they've seen before.
Exactly.
And that's where typos come in, right?
Yeah, typos are kind of like a sneaky type of noise. They can really change the meaning of a sentence, even if it's just one letter.
Makes sense.
And it seems like English is especially vulnerable to this.
No, really?
Yeah, they found that English was the most sensitive to noise compared to the other languages they tested.
Why do you think that is?
Well, they think it might have something to do with the way that typos affect the meaning in English, particularly with verbs and nouns.
I see what you mean. Like change one letter in a verb and it totally changes the action.
Right, like walk versus work or hear versus fear.
Yeah. Small typos, big impact.
Exactly. So we've made a lot of progress, but it's clear that there's still a long way to go to make these systems truly robust in the real world.
Especially with how messy human language can be.
For sure. It's not even just about typos, though, right? It's like all these other things like slang and dialects and even emojis.
Yeah, it's like asking a computer to understand this constantly evolving thing.
Totally. And that's where this research gets really interesting because they didn't just like point out the problem. They actually started looking at potential solutions.
Okay, so is there like a way to make these systems more robust?
Well, one thing they tried was training LLMs on like noisy data.
So like intentionally introducing typos and errors into the training set.
Yeah, exactly. Kind of like giving the AI a crash course in human fallibility.
I love that. Instead of trying to shield it from errors, you're exposing it so it can learn to deal with them.
Right, and it actually worked pretty well.
Oh, really?
Yeah, they found that the models trained on the noisy data were way better at handling real-world text.
So it's like that saying, what doesn't kill you makes you stronger.
Exactly. And this whole idea of like introducing noise during training isn't new. It's called data augmentation, and it's used in all sorts of machine learning tasks.
So it's not just about making AI more resilient to typos, but also making it more adaptable to just like the messiness of real-world data.
Exactly. And that kind of brings us to another interesting part of this paper, which is the types of LLMs that they tested.
Okay.
So they didn't just focus on those massive models, they also looked at smaller ones and even models with different architectures like decoder-only models.
Can you break that down for us? Like, what are decoder-only models?
Sure. So they're trained using this technique called next token prediction.
Okay.
Basically, you feed the model a sequence of words and it tries to predict the next word.
Like a really fancy autocomplete.
Yeah, exactly. But here's the thing. They found that decoder-only models like Bloom and Falcon were actually way worse at handling typos than other types of LLMs, especially on tasks like named entity recognition.
Named entity recognition. Remind me what that is again?
Oh, yeah. So it's this task where you have to identify and classify like named entities in a text, like people or organizations or locations.
So it's like highlighting all the important nouns.
Exactly.
So these decoder-only models that are great at predicting the next word struggle when it comes to identifying these entities, especially when there are typos.
Right. And they think it might be because of how these models are trained.
Like, because they're so focused on predicting the next word, they get thrown off more easily by something like a typo that disrupts the flow.
Yeah, that's the idea. It's like if you're reading a sentence and you hit a misspelled word, it can totally throw you off.
Totally. It makes sense.
And it's different from other types of LLMs, like encoder-decoder models, which are trained using masked language modeling.
Okay, so what's the difference?
So in masked language modeling, you basically mask out some of the words in the input text, and the model has to predict the missing words based on the surrounding context.
Like a fill in the blank for AI.
Yeah, exactly. And this seems to make them a lot more robust to noise because they're forced to consider a wider range of possibilities, even if some of them are wrong.
Interesting. So it's like they have a bigger vocabulary to work with, so they're not as easily thrown off by a single misspelling.
Right. And it makes you wonder if there are ways to like tweak the training process for decoder-only models to make them more robust without losing their strengths.
Yeah, that's a really cool thought.
And actually that leads us to a perfect point for novel notions.
Oh, yeah. Let's get to that.
But before we do, I just wanted to mention one other key takeaway from this research.
Okay, what's that?
So they found that just testing LLMs on clean versus noisy data isn't really enough to get a full picture of their robustness.
Makes sense, I guess.
Yeah, we need like better methods that can take into account all these different types of noise and different tasks and different languages.
It's like the difference between testing a self-driving car in a lab versus testing it out on a busy street.
Exactly. And that's why we need better evaluation metrics that can really measure how these systems will perform in the real world.
So it's not just about accuracy. It's also about transparency and being able to trust these systems.
Absolutely. And that's where data sets like WikiTypo come in. They give us a more realistic benchmark for training and evaluating these models.
Awesome. So anyone working on AI needs to check out this paper.
For sure. It highlights some really important challenges and points to some really exciting new directions for research.
All right, so let's move on to novel notions.
Yeah.
This is the part where we get to be like super creative and brainstorm some like crazy but kind of plausible ideas for future research.
Right.
So what are you thinking?
Well, this paper got me thinking about how we can make these LLMs even more robust, you know? Like, what if instead of just tolerating typos, the model could actually, like, learn from them and get better over time?
Whoa, that's like a self-correcting AI.
Exactly. It would constantly be updating its knowledge base based on all the little mistakes it encountered.
For like the more typos it sees, the smarter it gets.
Right. We could call it a continually learning robust LLM, or CLRL for short.
I love it. And think about what that could mean for things like machine translation, you know, where all those little nuances in language can really trip things up.
Yeah, like a CLRL could learn from the mistakes it makes in translating slang or idioms and just keep getting better and better.
It'd be like having a built-in language tutor that's constantly evolving with you.
Right, and it wouldn't just be limited to translation. Think about things like sentiment analysis, where the model has to understand like the emotional tone of text.
Yeah.
A CLRL could learn to better interpret sarcasm or humor or even like cultural differences in how people express emotions.
It would be like a superpowered AI that understands not just language, but also culture.
And here's another idea. What if this continual learning process was multilingual?
Okay.
Like imagine a whole network of CLRLs, each specializing in a different language, but all sharing what they learn with each other.
So a typo in one language could help refine the model's understanding of another language.
Exactly. It would be like a global AI brain constantly learning and adapting to the way humans communicate.
That's amazing. It's like the ultimate language learning tool.
Of course, there would be challenges, Like, how do you make sure that AI is accurately identifying and categorizing typos? And how do you avoid introducing biases into the learning process?
Right. Those are important considerations.
But the potential benefits are huge. I mean, this could really revolutionize the way we interact with technology and with each other.
And it all comes back to this idea of understanding the messy reality of human language.
Exactly. It's not just about fixing typos. It's about building AI systems that can truly grasp the nuances and complexities of how we communicate.
Yeah, and who knows, maybe one day these systems will even start contributing to language in their own unique ways.
Right. That would be pretty wild.
All right, well, I think that's a great place to wrap up this episode of Talk Tensors.
Yeah, that was a good one.
We've covered a lot today, from the surprising fragility of LLMs to the potential of continual learning and, of course, novel notions.
It's been a great dive into the world of AI and language.
Thanks to everyone for listening, and as always, we encourage you to check out the full research paper linked in the episode description.
And let us know what you think on social media.
We love hearing from you guys, so until next time, keep those algorithms learning, and
may your data be ever so slightly messy.
See you all on the next deep dive.